Hey, it's Joseph over at zchg.org, just bringing you an update. Okay, so I've built a Docker container for you, and this Docker container contains an AI bot trainer or a machine learning trainer. This also uses Lavenstein, and it also uses, I think it's NLTK, something like that. Let's see, NLTK. So Lavenstein, I apologize if I mispronounced that, and NLTK. And then the machine learning stuff we've got here. And what it basically does is it runs through and has two sentences compared against one another. Now you might notice in a second when the color starts to populate, there's some of it, it'll populate with other colors. You might start to notice it looks just like a traditional proof of work miner, and the reason is that it is sort of like a miner. What it's doing is it's mining for sentences to be compared with one another. Now there's a certain problem with this particular version, which I'm working on correcting now. The trainer would train against random two sentences. I thought the two sentences were related to one another, and that was my error. There may still be some practical application for that error that I made, and in that you basically have pretty close to true random, close enough anyway, with respect to choosing two sentences. But in any case, that's not what I was trying to do here. I was trying to train it with some conversational sentences. And we need to find a better library, but the point is you can train any library or across itself. So real quick, let's pause. Let's pause this simulator, this bot simulator. What it's doing is it's training itself by talking to itself. And you can see here that there are two context files. Well, there are actually many context files, but there's a private with respect to that particular instance, that bot. For example, zchg.org 7 is one of the many bots. Okay, I'll show you this real quick. One of the many bots that is being trained. And so there is an individual context file component, and there is a shared component. And the idea is that the shared component of the context only receives the highest accuracy score compared sentences. Now early on, when you just start the bot, we're only at iteration number 4. You're going to have really low accuracy scores. As this goes up, the shared context database will only receive higher accuracy score simulations, training data. Excuse me. So you can see this score, not 0.087, resulted in, early on at least, a nice shared score, which as before looks just like mining, and that's no accident. So let's unpause. Let's see how it's been doing. Okay, and it's still doing the same thing. It's comparing one sentence against the other, and it's going to create your averages, your shared accuracies. Now, as before, this thing is just going to create more or less a random score for it, so it won't be able to ever improve per se, very quickly anyway, because there's a little too much random going on with respect to the one sentence to the other. Now we still, as before, we need to find a library that can do that conversational comparative sentence simulation. But let's go over to, and notice real quick how it seems to be going relatively fast, but let's compare it to what I'm going to load next. Okay, I'm gonna get this instance with the Control C. And by the way, you can download that one on our GitHub and test it for yourself. I think I was pulling for that instance. I was using pretty much this one, 0.0.5b. You can go to github.com/zchg.org, and then it's your AI trainer being your subfolder. But that exact link will get you exactly where you want to go, and you can even do it for yourself. And all I did, once I've got those files that I need loaded onto a folder, this is designed specifically for CentOS 8. You're going to have the most success there, but of course you can use it across other platforms. that command is the only one you need, and that is accessible on the README, which is, let's see, where did that README go? There's that README. This should be, it's a derivation of that, but I like to cheat, not really cheat, I like to go fast, so we'll do that. Now, I told you I was going to show you the other one, so we're gonna rename this to something else. Excuse me while I do this really quick. And then we're going to find demo and we're going to rename it to bot. All right. Now this version you will not be able to see as of this recording, although I'll probably release it here shortly. What I did was I added Wikipedia. I also reintroduced an earlier simulation parameter whereby any generated sentence, the second sentence, has 100% accuracy, and it's attempting anyway to relay that accuracy to the self-improved functionality of the bot. The idea being, okay, well, this is a perfect score. This is exactly what you wanted to predict, and let's see side by side how the machine learning did with respect to that perfect score. So once this loads, what you're going to see is that instead of using the LTK library, we are still using the Lavenstein, and to a point we are still using the library, but we're not using it any longer for this instance to generate the simulated conversation. And instead what we've done is we've used Wikipedia. And at first I had a big problem using Wikipedia because it would give me lots of errors, only trying to download 2 sentences at a time. So instead what I did is I downloaded an entire article at a time, and we parsed through the entire article sentence by sentence, and we'll see that load here right about 9 out of 20. It'll be here in just a second. Let's move this over here so I can multitask with you guys. All right. Cool. That'll load. And then we're going to look at how this all kind of ties together. So as before, I mentioned it was a minor. Oh, there it goes. So it's going pretty fast, you can see. It's going very fast compared to the previous version. And just so you're aware how it does have, if I didn't say before, you can choose the number of bots, and we can see that our processor usage is fairly high for this version. It's actually pretty mellow. If I had shown you this when the other instance was loaded, you would have been able to see that the processing time, it was all bound up. But in any case, the idea behind these AI trainers, they require an enormous amount of sentences or paragraphs or pages to compare side by side. And to accomplish that, you basically break into your multi-threading, multiprocessor, and later on, or we have the primitives for it now, but later on we're going to start to introduce the GPU acceleration. Like I said, you can already download the primitives for that GPU acceleration. But the idea being, we've got a new platform, a new model set up for proof of work, only it is a minor. Okay, so you can see our old network still runs in the background to this day, and that is a proof of authority. But this is going to be what I'll call proof of AI work, PAIW, or maybe PoAIW, I don't know. In any case, pause it real quick. You can see the accuracy is 1 in reality, whereas the simulated accuracy, the improved accuracy, is not 0.5. Now remember, I just started this trainer. You were watching me start it, so it hasn't iterated through enough sentences. But you can see the first sentence, Eden was well regarded at yada yada yada, and then he eventually returned to Maryland, where he died in 1784. So it is, in fact, one sentence compared beside the exact correct sentence that would have been used by that structure. And so if we extrapolate this, what's going to happen, it's going to use a combination of the Lavenstein library and the NLTK library and the machine learning library itself to come up with the best possible score. And so you'll see this number improve if you've got enough cores running. So you need a lot of cores, and so this mining thing comes into play because now you can tokenize these essentially what are hashes. Now check this out. I'm going to break that instance. Hopefully it breaks. Sometimes I need to make it so that it's a protocol for breaking instead of Control C. But in any case, what was I going to do here? Come on, go ahead and break for me, bud. Technical difficulties. Any case, what I was going to show you, let's see if we can duplicate it. Yeah, let's do that. Come on. I'm just going to do a Docker, what is it? The prune command. I forget the command. This messed me up. Anyways, I was going to show you that each Docker container can be assigned an SHA 256, which is sort of like what Ethereum miner will go for. The SHA 256 container itself is one instance containing a myriad number of those bots, which if we get our graphics card going a little better, we could say something like, 5,000 or 5,000 bots, right? And so each individual bot has its individual context file, and they also share those context files across the entire bot universe, be it the one container, the many containers, or the mining network of containers. And so the idea being we repurpose that proof of work useless hashing with something purposeful. It being a AI blockchain-based, blockchain siloed AI utilizing the inherent SHA 256 hashing that containerization provides in the first place. And the idea being also that you can swarm those bots and basically scale up your, oh, that's why I couldn't break it. Cool, I'll be able to actually show you this. I had it on pause, so it doesn't let you break when it's on pause. We'll go up to system and not install current. There we go. Yes. So you can see we had that SHA 256 container, and thereby we're able to assign each bot its own hash. We're able to assign swarms of hashes in that way, and each bot is able to cooperate in that way toward the end goal of getting that machine learning to run efficiently. And so enter the network, which we are going to port to here shortly. The network will be able to silo the data, the high quality data, and it will also, of the bots, and it will also be able to facilitate the creation of a swarm of more bots. And those bots will be produced in distributed fashion thanks to anybody who wants to run their own node. And this creates an inherent just native distributed AI mining platform. And so you can see one of the arms that we are developing towards, although we are still going to have the offline native arm, which is going to be more of a like if you want to be able to write a check offline, or if you wanted to remain completely anonymous, that particular network will have the interfungible, interoperable tie-in. We may or may not keep the original proof of authority network, and we're going to be able to have a much more powerful and purposeful proof of work network, which can exist beside the proof of authority network and the other networks, Ethereum, Fusion, and all those other networks. Although it doesn't require those things. That's the nice thing about interoperable or interfungible. Although it does make sense to continue that, that Web3 component that we pioneered, that interoperability permits for essentially finding the most efficient way to solve whatever problem you're trying to solve. In this case, we're just trying to create a really smart AI bot that gives AI tech to everyone. Everyone owns it. You can contribute your own processing power, the idea being anyway that you can contribute your own processing power and or borrow the processing power of others. And so there's going to be a give and take, and you sort of like SETI at home. I don't know if anybody remembers that, but back in the day, I don't know if it's even still running. It probably is. You could donate your spare computing resources to the AI to make it more powerful. You can tokenize that. And so I see big potential for zchg.org's own coin, which is called CHG Coin, to re-enter into the limelight a little bit with the next generation of network, which is going to be more of this proof of AI work concept as the one network, and then we've got the other network, the offline native, and we could even have this third network as the proof of authority, and I would say the fourth network being all the other networks that you can tie into in order to further increase the efficiency, the processing power of your network. At the end of the day, it's an economics problem, and so why not map to the most affordable network, which just might be zchg.org. You might want to check out my other video where I talk about that. My last video, actually. Anyway, pretty excited to share that with you. I think it's going to be really cool. I think you might begin to see how we are following the roadmap toward the peer-to-peer internet, the AI on the blockchain, which we started researching back in 2016 when I had a meetup group there in Loveland, Colorado, and we started developing then when we had a little tiny think tank of people native to the Loveland, Fort Collins area who were just coming to hang out and talk about AI that relates to the blockchain. Now, as you can see, it's evolving toward this functionality. In any case, I'm going to break that. Show sites and get you on your way. Let's see. Don't forget to go to trade.zchg.org, and that should allow for you to learn how to trade and take part in getting some CHG for yourself. Check out that app, hub.zchg.org. Our main website is just zchg.org, but we also have wecharge.com, which is the electric vehicle tie-in to all of this. And as before, you go to download that trainer for yourself, see how it works. Those are older versions. I've got newer versions locally. I'll be releasing those soon. And check it out for yourself. Let's see. Okay, I think that was everything. Let me go check with my associate. Was that everything? All right. Yeah, that was everything. All right, you guys take care. Have a nice day. zchg.org. We charge without e.com. wecharg.com. Take care.